Here's a new take on the conversion between grams and moles. This is a technique that certainly will make stoichiometry a whole lot easier when we eventually get to that in a couple days. So let's review what we've done in the past. So this is from our previous consideration of gram-mole conversions. So just to kind of summarize again, if I have grams of carbon, and it looks like I've typed in something that looks different than the 1.25 grams, so I don't know if that's supposed to be 1.25, and I've got 1.85 there, but nonetheless, if I have grams of a substance, then in order to get to moles, I divide by the grams per mole. So I've got the grams of carbon on the bottom, it's 12.01, we get that number off of the periodic table, and that represents the mass in 1 mole. So if I just follow through using the labels to guide me, I get 0.154 moles. So if we're paying attention here, what we're doing is we're taking the grams of carbon and dividing by the molar mass. So this quantity, the grams per mole, we could call the molar mass. Okay, so likewise, if I start out with the moles of a substance and I want to get to the grams, then what I do is just do it the other way around. I've got the grams on top. I'm going to have the moles on the bottom, so I cancel out the moles and I'm going to end up getting grams. So if I just multiply through the top, I'm going to get the grams of gold that are equivalent to the given number of moles. And if we have more complicated substances, more than just a single element, then we can again add up the atoms that are involved in the substance. So if I have water, then in order to find the molar mass, I have to add up 2 hydrogens and 1 oxygen. But nonetheless, if I'm starting with the moles are going to go on the bottom in the next cell, and the grams are going to go on the top. So I just multiply across the top to get the number of grams of water that I would need to supply, in this case, 47.3 moles. And then the opposite is true. So if I've got grams of this substance, and it looks like it's probably a monosaccharide like glucose, so I add up 6 carbons, 12 hydrogens, and 6 oxygens to come up with the molar mass of 180.16 grams in 1 mole. But because I'm starting with grams, I'm going to put the grams in the bottom and put moles in the top. And then I just essentially divide by the molar mass. So if I've got the grams, I'm going to divide by the molar mass, and if I've got the moles, I'm going to multiply by the molar mass. Okay, so just to kind of summarize, if I've been given grams and I need moles, I'm going to have to divide by the molar mass. If I've got moles of an element or compound, then I'm going to have to do the opposite. I'm going to multiply. And one way to set this up is by using the table that I have on the next slide here. So I need to find the moles of each of these quantities here, and what I do is I set this up like this. I start out with my grams on the top, grams per mole in the middle, and then moles on the bottom, and I do this always. And the molar mass, I'm either going to get from the periodic table, and if it's just a single element like gold or oxygen, well, oxygen I have to be a little bit careful because oxygen is O2, so you have to look at the formulas. So gold I can get directly from the table. Oxygen, because it's diatomic, I have to add up twice the mass of a single oxygen atom. And then likewise for the others, I just add up the masses according to the formulas. So in order to get from mass to molar mass, I divide down. So one thing I tell students is that the D and the D go together, so dividing down. So if I need to go down the table, I need to divide. And if I do that, I get the corresponding quantities of moles for each of these substances. Pretty simple, pretty easy. Excuse me. The other way around, if I'm starting with moles and I need to get to grams, well, I'm going up the table, and up is the opposite of down, and in my way of thinking, multiplying is the opposite of dividing, so I'm going to multiply up. So that's what we're going to need to do. So doing that. So if I type in first, so I got to start at the bottom of the table, and I would type in the case of gold, 8.1, and then times 197. So the order that you do this is important. So if you're at the top of the table, you type that number in first, and then the mathematical function to get down. In this case, we're going up the table, so we're starting with the bottom information and multiplying up. So I can calculate each of the corresponding gram quantities, and I'm trying to do the best I can to pay attention to significant figures. And that's about it. You divide down and you multiply up. Some people absolutely love this approach, and some people that have encountered chemistry before and have practiced a lot using factor label method, the horizontal method, want to stick with that. So whatever works for you is fine, but I would say that if you're not that tied into that factor label method, I'd say give this one a try, because when we get to stoichiometry, you're going to be solving problems 10 times faster than the people that are doing it by factor label method.